Hi, I'm Michael Moorhead, a co-founder and the CEO of Syglass. Over the past 10 years or so, new imaging technology has allowed the basic science researcher to collect very large, high-resolution 3D image volumes of their samples, providing an unprecedented view into the microscopic world. At Syglass, we've developed software that allows those researchers to explore their data in virtual reality. This is a really powerful tool. However, often the scientist needs to interact and quantify that data while they're exploring. Unfortunately, the graphics processing unit, or GPU, is often saturated by the volumetric ray tracing that we perform inside of Syglass. Due to nonlinearities in the imaging process, traditional imaging processing algorithms are insufficient in their accuracy or throughput to provide these scientists with the answers that they need. That's where deep neural network technology comes in. It can provide very quick and accurate results for the scientist. Unfortunately, the GPU, which is traditionally used for deep convolutional neural networks, is completely saturated by virtual reality ray tracing. That's why I'm so excited about this new hardware from Ara. This is a USB plug-and-play device that acts as a deep neural network inference machine. Once attached to any computer, you can send it 2D or 3D image data. It will run it through a deep neural network that's already been trained and give you the results, often in a matter of just milliseconds. This is really powerful and allows the scientist to act as a human in the loop in the middle of their algorithms and exploration of their data. Let's go into VR now and check it out. One of the first things to note about virtual reality, and especially volumetric ray tracing, is that it's incredibly GPU intensive. I'm going to load some relatively larger data, and let's take a look at the GPU usage here on the screen. So here we can see with just some regular slicing and dicing of the data, GPU saturation is pretty high, and the video RAM is nearly saturated at 6.9 gigabytes out of 8. Now I will attempt to run a conventional deep neural network while utilizing the virtual reality. Please note that there is some dropped frames, some low frame rate in the VR visualization system, as well as a complete failure of the deep neural network to instantiate due to lack of available video RAM on the GPU. And this makes perfect sense, as the GPU is busy holding all of that image data for ray tracing visualization. Now, instead, let's try to perform the same algorithm using the Deep Vision USB inference device. Note that the Ara and Syglass engineering teams have worked together to integrate this pipeline directly into the visualization system, allowing per pixel classification of these cells. This specific inference is very important to life science researchers. Cell counting among various experimental conditions is a crucial task for understanding drug effects on cell populations, but counting thousands or millions of cells manually is an extremely time-consuming task. By automating the segmentation of cells, life science researchers will save huge amounts of time in counting, and as an added bonus, will also get volumetric and morphological metrics to better understand changes in conditions. Real-time visualization results will allow researchers to correct neural network errors on the fly, increasing the inference accuracy over time. In conclusion, this is an exciting new development in machine learning hardware. The extremely low cost of this device means this solution can be deployed at any budget. The fast inference visualization edit loop will mean faster throughput for research scientists, leading to bigger discoveries for mankind.